Now we want to move on to look at the steady state of the economy from the Solow model and solve for it numerically. But before we do that, we need to come up with the steady state condition for the Solow model under the assumption that there is population growth and the technological growth. So given that the equation number 3 is the law of motion that characterizes how does the variable evolve over time, therefore we want to focus on this equation to come up with the steady state condition. It turned out that we can write it out explicitly, the multiplication of 1 plus g and 1 plus n, and then we are going to have 1 plus g dot n plus g plus n in front of the kt plus 1. So then if the economy is in a steady state, we already know that the lowercase kt plus 1 need to be equal to kt. Therefore, we can set the kt plus 1 equal kt and then solve for the equation, and then we are going to get a steady state condition. It turned out that the steady state condition equals 1 plus g plus delta plus n multiplied by g, the whole thing multiplied by kt. So then given that the n and g are relatively small number, because it will be, for example, 5%, 2%, 1%, so then we know n multiplied by g will be a super small number. Because of that, we can assume that the product of n and g approximately equals 0, and then we can drop it, so that we are going to have a relatively clean steady state condition, look similar to what we had before, which is that the investment required at a steady state equals n plus g plus delta multiplied by kt. So the only difference of this steady state condition versus the earlier steady state condition is that we have the g in the steady state condition. So then, based on this steady state condition, we also want to draw the Solow diagram and solve for the steady state of this model numerically. So to begin with, we want to look at how to solve for the steady state for the Solow model under the Solow diagram. If you may see in here, the only difference of this Solow diagram from the previous Solow diagram we draw is in here. That is, now the steady state condition is different from our earlier steady state condition, because now we have the technological growth and the population growth. So then to come up with the steady state, we know that if we are below the steady state, then we are going to have the actual investment greater than the investment required to stay at this level of the capital stock. Therefore, the economy will have the K that increases over time until it hits the steady state. On the contrary, if we are below the steady state, then we are going to have the actual investment that is less than the investment required to stay at this level of the K. Therefore, we are going to have the K that falls over time until it hits the steady state. So then we know under this model, once the economy is at a steady state, it's going to stay there, but should there be any shock that causes a deviation from this steady state, the economy will gradually move back to the steady state. So now we want to solve for this steady state numerically. What we know is that the investment equals the savings, which is an equation combining the household decision that the consumption equal a portion of the output and the equilibrium condition, that is whatever amount of the output need to be either consumed and invested. From these two equations, we are going to get a new equilibrium condition, that is the total investment need to be equal to the total amount saved. On the other hand, we have another equation, which is from the law of motion, that tell us if the economy want to stay at a certain level of the capital stock, then this is the amount of the investment required to achieve this goal. Therefore, when we look at these two equations, after we put in production function into the output, so then the four equations under the Solow model degenerated into two equations for solving the Solow model. So then what we know is that if the economy want to stay certain level of the K, then the actual investment need to be equal the investment required to stay there. So we combine these two equations, we are going to have this equation in here, and then we can divide both sides of the equation by kt theta, and then what is left is n plus g plus delta multiplied by kt to the power of 1 minus theta equal SA. Therefore, we can continue to solve for it, and then we are going to get the value of the K steady state under our new version of the Solow model with population growth and the technological growth, which equals S multiplied by A divided by N plus G plus delta, the whole thing to the power of 1 over 1 minus theta. If you may recall from what we learned before, we said that for the model with population growth only, we are going to have the K steady state equal SA over N plus delta, the whole thing power to the 1 over 1 minus theta. If the model is with no population growth and technological growth, then the K steady state equal SA divided by delta, the whole thing to the power of 1 over 1 minus theta. So then how to link the result we get from the model with population growth and the technological growth to our earlier results? Well, for the first case, if there is no technological growth and population growth, now when we look at the results from the model with population growth and the technological growth, we know that we can cross out the G, and then we are going to have the result exactly as what we got before. Similarly, to look at the second case, when there is no population growth and no technological growth, we can assume both the G and N equal 0. So then let's take a look at the result we got for the model with technological growth and population growth. We know that once we cross out the N and G, and then we are going to get the result exactly the same as before. So this is how we come up with the steady state for the Solow model, for the model with population growth and the technological growth. So you will clearly see that the logic for coming up with the steady state under this new version of the model is exactly the same as the logic we used before. So now let's move on to look at the golden rule under the new version of the Solow model. Now let's try to find the saving rate that maximizes the consumption, which is called the golden rule saving rate. So as you may recall from what we learned before, that based on the Solow diagram, we know that when we are having a model given a saving rate, then we will be getting to know that the savings need to be equal the actual investment in equilibrium. And then when this investment satisfies the steady state condition, then the intersection of these two lines will then determine the capital stock in the steady state. But if for our model are given another saving rate, then we are going to have another intersection of the actual investment and the steady state condition, and then we are going to get another capital stock in the steady state. So then under these two models, we know that for each corresponding level of the K steady state, we are going to have the corresponding level of the output. So the height highlighted by purple is the size of the output. Moreover, we know that the point highlighted in orange is the size of the investment. So then the distance between the purple dot and the orange dot is the consumption. So then we know that when we are given a higher saving rate, then we are going to have a higher output in the steady state. But it is not necessary we are going to have a higher consumption. Therefore, there exists an optimal level of the saving rate that maximizes the consumption. To find out this saving rate, we know that for an economy that has the distance between the output and the investment is largest, we need to find the point where the tangent on the output line, which is the concept of the marginal product of the capital, need to be equal the slope of the steady state condition, and then the consumption is maximized. That is because when the line that tangent on the production function that parallel to the steady state condition, then we are at the hilltop, the hill that highlighted in yellow. So then we know that, so the saving rate in here that is drawn by the curve in red is the golden rule saving rate, and the corresponding capital stock is the golden rule level of the capital stock. So then to find out the number for the saving rate that maximizes the consumption, we know we can set the slope of the steady state condition equal the marginal product of the capital. And then we can solve for this equation. We are going to get the golden rule level of the capital stock equal theta multiplied by A divided by N plus G plus delta, the whole thing to the power of 1 over 1 minus theta. So then if you recall from what you learned before about the K steady state we get a few minutes ago, then you will notice that for any model given a random saving rate S, then this is the capital stock in the steady state we are going to get. But to come up with the model that turned out to have the consumption that's maximized, then the saving rate has to be theta. Therefore, when we compare these two results, we will get the golden rule saving rate need to equal theta. So that is how to come up with the golden rule saving rate from the diagram. Now we want to solve for it numerically. To solve for the saving rate that maximize the consumption numerically instead of from the Solow diagram, we know that we are trying to find a capital stock in the steady state that maximize the consumption. Given that we know consumption equals the output minus the investment, so then in here we can plug the production function into Y and plug the steady state condition into I. And then we can solve for the maximized consumption by choosing the K. And then we are going to have theta A, K to the power of theta minus 1 minus N plus G plus delta, and then set it equal 0. For the K that satisfies this equation, then the consumption will be maximized. So then we know the theta A K to the power of theta minus 1 is the marginal product of the capital. So then we can rearrange the equation, and then we are going to have the K that equals theta multiplied by A over N plus G plus delta, the whole thing to the power of 1 over 1 minus theta. And this is the golden rule. K is because this K is the K that maximizes the consumption. So then once we know the result for the K that maximizes the consumption, we want to look at the steady state condition to find out the relationship between the saving rate and the capital. So what we do in here is that we plug the production function into the Y, and then we are going to have the new version of the steady state condition, that is S A K theta equals N plus G plus delta multiplied by KT. And for this equation, we will come up with the relationship between the saving rate and the capital stock. So then, given that we know when we are having a capital stock that maximizes the consumption, that is the golden rule capital stock, then we can plug this result into this equation in here, and then we are going to have the golden rule saving rate. And from this equation, we know that we can cross out the A, the N plus G plus delta, and cancel out the 1 over 1 minus theta and to the power of 1 minus theta. And then at the end, we are going to get the golden rule saving rate that equals theta, which means that we can come up with the golden rule saving rate either from solving the equation that maximizes the consumption by choosing the K, and then plug this K into the steady state condition, and then we are going to have the golden rule saving rate. Another we can do is that we look at the Solow diagram, and we can tell that at the time the consumption is maximized, it is when the marginal product of the capital equal to the slope of the steady state condition. And then we can solve for it and compare this particular version of the capital stock steady state versus the general form of the capital stock steady state. And then we will be able to infer that for an economy to have its consumption maximized, its saving rate is the golden rule saving rate, and it needs to be equal theta. So then in here we finish the discussion related to how to come up with the capital stock in the steady state and the golden rule saving rate under the new version of model. The logics are exactly the same as what we had before.